Problem number 4. We call the expressions a plus b and a minus b conjugates of one another. The directions say take each expression shown and multiply it by its conjugate. So the conjugate for sine x plus 2 would be sine x minus 2. Just change the sign in the middle. Okay, now I have a FOIL problem. Well, the thing is, when you do these conjugate FOIL problems, you realize they work out pretty nicely because I will have the first, sine x times sine x is sine squared x. But look at the outer and the inner. The outer, you get minus 2 sine x, and the inner, you get plus 2 sine x. They wipe each other out. The only thing I would have left then is the last, 2 times negative 2 would be minus 4, and I'm finished. Sine squared x minus 4. Letter B, the conjugate of 2 cosine x minus 3 would be 2 cosine x plus 3. Again, I'll FOIL. 2 cosine x times 2 cosine x would be 4 cosine squared x. The middle pieces are just going to wipe out. It's a 6 cosine x and a minus 6 cosine x. And then you get minus 9 from the end. And once again, I'm done. In problem 5, we want to rewrite each expression as simple as possible. When I look at letter A, of course I'm seeing a sine squared and a cosine squared. That makes me think Pythagorean identity. What about the 9 though? Well, what I can do is I can factor out that 9. It's a GCF to both parts. And when I do that, the parentheses is sine squared x plus cosine squared x. Well, that's just equal to 1. 9 times 1 is 9 for the final answer. Letter B. I've got a lot going on here. Again, when it's hard to know where to start, switching to sine and cosine can be a good idea. 1 over secant x, I can just reciprocate that secant x to the top and make it cosine x. Same thing with the second fraction. I have cosecant squared x on the bottom. I can just reciprocate that to the top and make it sine squared x. And as soon as I write this down, I see that this works out pretty nicely because I have a cosine squared x plus sine squared x. Cosine squared x plus sine squared x is 1 plus that other cosine x I had. This is as simple as I can write this expression, 1 plus cosine x. In problem number 6, we're being asked to add or subtract. We want to simplify our answers. Of course, we're going to need common denominators. So when I look at part A, one of them has a sine x, one of them has a cosine x. I'll just have to fix each one for what's missing. The first one is missing a cosine. The second one is missing a sine. Just do the same thing, top and bottom. So that's going to give me 4 cosine x over cosine x sine x plus 4 sine x over cosine x sine x. Now that the denominators match, I can go ahead and add. So I have 4 cosine x plus 4 sine x. Those are not like terms, so I'll just have to write them down. And the bottom stays the same, cosine x sine x. When you get to the end, you can only cancel, you can only divide out common factors. So the bottom is factored. It's a times problem. The top is not factored. It's an addition problem. Now I could factor it. The only thing I could do is I could pull out the 4. That would leave me in parentheses with cosine x plus sine x. The problem is there's no 4's on the bottom and there's no cosine x plus sine x's on the bottom, so I wouldn't be able to cancel anything. This then is the final simplified answer. Letter B. It would probably help if I put a 1 under here. Obviously the common denominator is just sine x. The first one has it. The second one needs to be fixed. That will then give me 1 over sine x minus sine squared x over sine x. Now I can subtract, and so I will get 1 minus sine squared x on the top, and then sine x on the bottom. Can I do anything with this? I can, because 1 minus sine squared x, that's one of those rewrites from the Pythagorean identity. 1 minus sine squared x is cosine squared x. And so I can write that just a little bit shorter. Final answer then would be cosine squared x over sine x. Part C, this one looks a lot like part A. The first fraction is missing a cosine x, and the second fraction is missing a sine x there on the bottom. And so when I make that fix, I get 4 cosine squared x over cosine x sine x, and then plus 4 sine squared x over cosine x sine x. And now I can add. I'm going to get 4 cosine squared x plus 4 sine squared x over that common denominator. And then look what happens on this one. If I factor that 4 out of the top, I'm going to end up in there with cosine squared x plus sine squared x. Well, that's just equal to 1, which means the numerator just ends up being 4. 4 over cosine x sine x. I think this is a fine answer. You could reciprocate those two trig functions on the bottom to the top so that it would become 4 secant x cosecant x. That does technically get rid of the fraction, although it introduces some of the messier trig functions. So either of those two, I think, would be fine. And then letter D, let's see, the first denominator is sine squared x. The second one is sine x. If I just multiply one more sine x here, then the denominators will match. So this one was fine the way it was, cosine x over sine squared x. What about this other one? What's cotangent x times sine x? Maybe I should go off on the side and do a little bit of scratch work. Cotangent x is cosine x over sine x, according to the quotient identity. And then if I multiply that by the sine x, I'm going to get some cancellation. All I'm left with there is cosine x. So this becomes cosine x over sine squared x. Well, look at what we have now. Cosine x over sine squared x minus cosine x over sine squared x. That's just going to be 0 when I subtract the tops. And there's my final answer.